Frequency distribution is a table showing the arrangement of the values of a data set and the number of times they occur. These are examples of a frequency distribution. A frequency distribution may be more detailed or less detailed than this, depending on the type of graph you want to use it for. The histogram is a graph that uses bars with no gaps between them to represent information from a frequency distribution. The class midpoint or lower class boundaries are on the horizontal axis, that is for the group data, and the frequencies are on the vertical axis. For the ungrouped data, you can have the max or whatever it is over here. Frequency polygon is a line graph formed by plotting the class midpoints against their corresponding frequencies. We include a class above and below in order for the polygon to touch the x-axis. Another way of drawing the frequency polygon is by connecting the midpoint of the histograms with a straight edge. Let's now solve some past questions for a better understanding. The marks obtained by 40 students in a mathematics test are as follows. So here are the marks distributions, and we are supposed to copy and complete the table for the distribution. So we have the class intervals over here. We need to count the number of marks that are falling within this class interval. So 0 to 19, we have 1, 2. So the tally is helping us count accurately. So we have 1, 2. So the frequency is 2. So within the interval 20 to 39, so we find a way to identify all the marks that fall within this class interval. So let's count them. We have 1, 2, 3, 4, then the fifth one we used to cross. Then we have 1, 2, 3, 4, then another 5. Then we have 1, 2, 3. So that is how we tally. So we count them and we have 13 of them. The next class interval is 40 to 59. So we identify all these numbers. So counting them, we have 1, then 2, 3, 4, and 5. We have 1, 2. So we have 7 of them in that class. Then 60 to 79. We identify all of them. So we have 1, 2, 3, 4, then 5. Then we have 1. So we have 6 of them in that class. Then the last but not the least is 80 to 99. So we identify all of them. 1, 2, 3, 4, and 5. We have 1, 2, 3, 4, then 5 again. Then we have 1, 2. So we have 12. Now, because the question demands that we draw a histogram, we add another column, that is the class midpoint. We could have also added or used the lower class boundary. So the class midpoint, we add the upper and lower class interval and divide by 2. So 19 divided by 2 gives us 9.5. Now 20 plus 39 will be 59 divided by 2 will give us 29.5. Then 40 plus 59 divided by 2, that will give us 49.5. Then 139 divided by 2 will give us 69.5. You could have also observed the pattern and find out that the next one over here is going to be 89.5, and so on and so forth. So we now draw our histogram using the frequency and the class midpoint. So we are drawing a histogram for the distribution. So we know the histogram is going to have bars that have no gaps. So the first one is up to 2, the second one is up to 13, and the next frequency, so still 13 over here, and the next one is 7. Then so this is up to 7. Then we have up to 6, but we draw the taller one, the taller boundary for the 6 and the 12. So we draw up to 12. Then the last boundary is also 12. Now we indicate the frequencies, that is the bar up to the frequencies. So the next one is up to 13. Then this one is up to 7. Then we have 6. Then we have 12. So we now use our histogram to determine the modal mark. So we look at the highest bar, then the one that is next to it and before the one and the previous one where it meets the longer one. We connect lines like this. So the tallest bar, look at the one next to it and the one before it, where it meets them, draw a line like this. Where the line intersects, drop to the mark axis and determine that mark, which is the modal mark. So from the histogram, the modal mark is equal to 32. And we have this one. The histogram shows the age distribution of members of a club. Use the information to answer questions 18 and 19. So we are supposed to find how many members are in the club. So we need to determine the frequencies of each of these bars. So for the first one, we have 0 up to 5, meaning that each of these boxes is 0.5. So to determine this frequency, we count these bars, and this is up to 4. So times 0.5 will give us 2. So the next one is 5, and the next is 8. We have 12, 11, then we have 7, we have 3, then we have 2. So sigma f is going to be a sum of all these frequencies. So 2 plus 5 plus 8 plus 12 plus 11 plus 7 plus 3 plus 2, and this is giving us 50. So the correct answer is 50. Now the next question says what is their modal age. So from the graph we determine the modal age, and that is going to be 44.5. If the question had asked us to draw a frequency polygon, then we would have joined the midpoints of the histograms by adding a cross above and below. So we use our straight edge and connect all these midpoints. That's why we are saying that drawing a histogram and a frequency polygon is almost the same thing. But it's not a necessity that you should draw a histogram before you can draw a frequency polygon. You could have used the midpoints to do that. So we connect this to this. That is why it is called a polygon. We connect them using straight edges. So this will connect to this, then this will connect to this. Let me do it well. So it's like going to look like this. So now let me delete this so that you can see clearly. So this is how our frequency polygon will look like, plotting the midpoint against the frequency. In short, we can draw a histogram by plotting the class midpoint against the frequency, or the lower class boundary against the frequency. Then we can also draw a frequency polygon by plotting the midpoint against their frequency. So we follow almost the same procedure in drawing the frequency polygon as in drawing the histogram. But it is not a necessity that you should draw a histogram before you can draw a frequency polygon.